given equation. At instant t is equal to 0, the angular velocity is 1 radian per second. So t is equal to 0, then omega angular velocity is 1 radian per second. That is, this is 1 is equal to b. At time t is equal to 0. And here a will be equal to alpha, the angular acceleration. Angular position is 2 radians at instant t is equal to 2. So they are discussing about angular position. Theta is equal to theta naught plus half alpha t square ut plus half a t square into omega naught t. Correct? S is equal to ut plus half a t square. So it is initially in this one. So alpha is a. Okay, and the second condition they are given is its angular position is 2 radians. Okay, at time t is equal to 0. So at t is equal to 0 means both will be 0. So theta naught is 2.
At t equal to 2 seconds, sir.
Angular velocity is its angular velocity is 1, and angular position is 2 radians. Angular position is 2 radians. Sorry, angular position is 2 radians at the instant of time 2 seconds. Sorry, yeah. So half into alpha into 2 square, and the angular velocity is 5 radians. Again, make use of this equation, first equation. So if you make use of the first equation, again you will get there alpha into 2 plus b is equal to 5, and b is already equal to 1. So therefore alpha will be equal to 2 radians per second. So you found out all the things.
Yes.
So you have to find out angular position theta, angular acceleration alpha when t is equal to 4 seconds. So you found out alpha. So this value is found out. This value is found out. So these constants are already found out here.
Yes, yes.
Okay. So then you know everything else is simple.
Yes, yes. The yesterday's equation will come very handy.
Yesterday's equation. Which equation?
Theta minus theta naught is half.
Half. Yes, yes. It's very important. Very essential. In that equation also can be used here.
Yes, that becomes simpler.
Yes, correct. So I suppose all of you wrote this and you solved this.
Yes, sir.
It's very simple problem. I
Yes,
suppose all of you have the answers with you,
Yes,
right?
sir.
So the first part, so we have taken it as theta naught. Here it's taken as constant c here. So we got omega is equal to 2. That is, sorry, theta naught is equal to 2 radians. That's what we also got here. Correct? And the second part,
Yes, sir.
the equation for t is equal to 2, just go on substituting, and we'll get all these constant values. We also got b is equal to 1, t is equal to 2 seconds. So we got a alpha is equal to a is equal to 2 radians per second. Okay? Substitute the one. I think all of you got this.
Yes, sir.
Theta at 4 seconds is 22 radians. Omega
Yes,
at
sir.
4 seconds is 9, and alpha
Yes.
is 2 radians per second. Quite a simple problem. Just what you say, you know, in cricket match, you know, first ball is a loser. Trial ball. Okay. Now this is a very interesting problem, right? Aram se, the problem may look humongous, but it's quite simple and interesting. Please study and aram se do this problem. All. Aram se. Don't be in a hurry. Unnecessary hurry.
So that move the tools.
Move the tools.
Okay.
See how beautiful it is and how nice it is. You can measure the speed of light using this method. Just a wheel is rotated with slots, and then light is passing, a small beam of light is passing. So I hope. Can somebody explain this problem? What you have captured from the problem? Somebody who never answers? Purtis, Vaibhavis, Aniket, Sarthak, Nishant. That category of students who never. Shreyas Patki, come on. Try and answer. I will help you. Don't worry. I am here to help you.
Sir, can I try?
Who is that?
Pratyush.
As usual. Yeah, somebody else other than Pratyush wants to try. If nobody tries, Pratyush can answer. Alright, Pratyush. Carry on.
Sir, this is a apparatus, sir, where it is used to measure the speed of light, sir.
Okay.
And it was used in olden days, sir.
No, don't read that. Don't read that. I don't want the theory like that.
Yes.
What is the physics behind this?
Sir, the materials required are a slotted wheel.
Hey, no. I'm not asking you to explain the experiment. Come on, try to understand. You are sitting in a classroom where you are getting trained for competitive exam. What is the physics behind it? Come on, quickly. See, you should capture. I want you to capture the information here such that it will help you to solve the problem. Okay, let me explain that. See, what happens is. But you right. Okay, Neela, try.
So, when the light beam is emitted from the light source, it passes through one of the slots on the wheel.
Okay.
And it goes and it gets reflected, and by the time it passes through the next, after reflection, it passes through the next immediate adjacent slot.
Yes, next immediate adjacent slot. Fine. Oh, good. Point number 1 is noted. Next. Then, how will you proceed to find out the velocity of light?
So the time taken to move one slot is
delta theta, delta t. So
yes.
the time that it will move from this slot to this slot, right?
Yes.
So this time interval is delta t. Correct.
Yes, sir. And the light beam will travel 500 meters twice, sir.
Twice. So it travels a distance of 2L.
Yes, sir.
Okay.
In the delta t interval.
Right. So then the velocity of light will be 2L by delta t. Correct? The velocity of light will be 2L by delta t. Hello?
Yes, sir.
Yes,
sir.
Now, in this case, L is given. Okay? And V is given. V you have to find out, gentlemen.
No, sir.
We have to calculate the angular speed of wheels.
Yes, sir. Sorry.
We can find that.
Measure. Okay, the velocity of light is given. Yes. So from this you will find out delta t. Thank you. You will find delta t. Wait. You will find delta t. Fine. You found out delta t. Then don't plug in the values initially, right? These things. See, you mark it. No, this is given. This is given, right? And delta t you will find out from this whole exercise.
Yes, sir.
Right. Now, so having found out delta t from this equation, then you have to proceed to find out the speed of the wheel. This is speed of light. Sorry, this is speed of light. Now you have to find out the speed of wheel. Okay.
So to cover one such slot, it takes time delta t. So for 500 slots, it will take 500.
Excellent. Speed of the wheel is v. This is linear speed of the wheel. So to cover one slot, it is delta t. So therefore, to cover full, that is 2 pi r. R is the radius. Has I given the radius? Yes. Yes, radius is given.
It's a 5
It's
centimeter.
5
So
centimeters.
this will be to cover this will be 500 into delta t. Okay, what is 500 into delta t?
The total time period.
The total time period.
Time period.
Total time. Yes.
Isn't it?
Yes, sir.
So 2 pi r. So this will give you the total time period. So 500 into delta t will give you what? The total time
Total
period.
time taken for one.
So into omega.
Wait. 500 into delta t will give you the total time period t.
Yes, sir.
Okay? Yes or no?
So yes, sir.
Yes, sir.
Now from this you can find out omega.
Omega is 2 pi r by 500.
Isn't it? What is omega? Omega is equal to
2 pi by
2 pi by t.
2 pi r.
2 pi by t. So you have just now found out t. So you substitute here, you will get omega.
2 pi. So 2 pi r.
2 pi r by t. And omega is equal to, I have found out this t, man. Period of revolution.
Angular.
Correct? No, period of revolution. T, capital T.
Yes.
Hello.
Yes, sir. Yes, sir.
So you find out omega. So if you know omega, then you have to find out what they have called speed, linear speed. V is equal to omega. Correct?
Yes, sir.
Radius is given, omega you have found out. So if you follow these steps, you should be able to get the speed. Clear?
Yes, sir. Yes.
Right? So this is, see, you should capture this problem systematically, and as you keep capturing the problem, you see, you should convert your thought process into mathematical formulation like this, and you should attack the problem. Okay? Hello?
Yes.
Yes, sir.
Yes, sir.
What is the constant angular speed of the wheel? What is the constant angular speed? So we have found out also omega, and we have also found out v from this.
Yes, sir.
Both the things.
Yes, sir.
Correct? Right. So I hope this is the methodology that is used, and I think this is fine. Right? So I think all of you captured it, got it?
Yes.
Yes, sir. Got it, sir.
So do you want to see the answer, or shall we simply proceed ahead? Shall we proceed?
Yes, sir.
Or somebody has solved this problem in this time? Has somebody solved the problem?
Yes, sir.
Have you got omega and v?
Yes, sir.
What is v and what is omega? Hello?
Omega is 3.92.
Ah, 3.9 you got, right. Radius speed 1.9 into 10 to the power of 2 meters. Good, well done. Right?
Yes.
See, the problem looks humongous, but just as you read the problem, you should be able to capture the information, convert that into math model. Okay? You should be calm and cool, and you should handle the things like this only. Right? So, if you have knowledge, right, and if you know how to apply the knowledge, then you are intelligent. And I am sure all of you are intelligent. Okay? It's just that you have to develop the right mindset to attack these type of problems. Right mindset is professional mindset. You should be calm and cool and composed and say, look, I can do it. I'll just keep applying the knowledge. Okay? And this is how you should keep tabulating the things and keep it. Fine, students. Be calm and cool and enjoy learning. See, as I told you earlier, you see, you will change. Your attitude has to change. Okay? And as we keep learning this chapter, lot of the previous chapters will get revised. Okay? So trust me.
Yes.
So that is how you know. So some of you, if you are feeling, oh, so many things we have studied and we are forgetting so many things and all. No question of forgetting. You don't have to read it repeatedly. Once you have understood, yes, and you are all engaged, whatever you have understood will be retained in your memory for quite some time, minimum of 2 to 3 years. Trust me, when it is really essential, the knowledge will come. If you have acquired it the right way. Right. Now, this numerical is about pulsar. So I thought I will tell you briefly about what is a pulsar before I go into the problem. Okay. Now, Pulsars radiate two steady narrow beam of light in opposite directions. Okay, so this pulsar is a star basically, right? Star in the sky.
Yes, sir.
Although the light from the beam is steady, pulsars appear to flicker because they also spin. That is, there's a star in one of the far off galaxies, and that star is actually rotating like this. Okay,
Yes.
and it is giving out one beam of light this side and another beam of light this side. Okay, and it is rotating, just like the lighthouse near the seashore.
Seashore.
Yes,
Huh. It is the same reason a lighthouse appears to blink when seen by a sailor on the ocean. As the pulsar rotates, the beam of light may sweep across the earth, then swing out of view, then swing back around again. To an astronomer on the ground, the light goes in and out of the view, giving the impression that the pulsar is blinking on and off. The reason
Yes.
the reason a pulsar's light beam spins around like a lighthouse beam is that the pulsar's beam of light is typically not aligned with the pulsar's axis of rotation. Okay, that is just it is going
Yes.
like this.
Sir, but why it should spin?
What can I do? Go and ask the Almighty. The star is spinning. Electrons are also spinning, no? So did you ask the teacher why it is spinning? It is spinning. This is physics. It is spinning.
Like
Earth is also spinning.
not sir, like the light rays that come from pulsars.
That is you see, that is a particular star. See, inside the stars, what is happening? Just like sun is a star, it is giving out energy.
Yes.
And what is happening inside it is thermonuclear reaction is taking place.
yes, sir.
Okay, similarly, reaction is
Correct.
taking place.
Yes.
It is giving out light from both sides. See, now it is this is not this one to discuss why it is doing and all. It is just that this problem
Yes.
we have to solve purely from angular rotation point of view.
So this even lighthouse also you spinning guys.
That star is spinning, man. Supposing I put a light torch in front of me, and I am spinning like this. What happens to you?
Light.
So same thing is happening here. It is just like that.
Yes, sir.
So, that was the pulsar's light beam spins. Means
ಈಗ ಈ ಲೈಟ್ ಹಾಕೊಂಡು ಹಿಂಗೆ ತಿರುಗಿದ್ರೆ ಸ್ಪಿನ್ ಆಗ್ತೈತಿಲ್ಲ
light beam spins.
it appears that the light beam is spinning. Okay, whatever it is just like lighthouse they have told now. Okay, just like lighthouse beam how it is spinning. Finish.
Okay.
See, that is why you will have too many questions. So I will explain what is a pulsar before I actually get into this problem. Now, a pulsar is a rapidly rotating neutron star that emits radio beam like a lighthouse that emits light beam. We receive a radio pulse from each rotation of the star. The period T of rotation is found by measuring the time between the pulses.
Yes.
Simple,
Yes.
right? The pulsar of a Crab nebula on the galaxy. Crab nebula has a period of rotation, so time period is given. That is increasing at the rate of 1.26 into 10 to the power of -5 seconds per year.
Yes, sir.
That means what? This
Acceleration.
is accelerated, and there is angular acceleration,
Yes, sir.
right? So the time period is increasing here. Time period is increasing means what?
Deceleration.
Time period is increasing. What is the math model for that? What is the math model for time period is increasing at the rate? What is the math model for the time period is increasing at the rate? If the time period is t, how will you give the math model for the rate of increase of the time period?
DT by
dt by dt.
Yes, sir.
T by dt. Yes.
yes.
Yes, sir.
Understood? See, what I am trying to make sure is, students, see, you convert that information into math models. Don't worry too much about the numerical. Whatever information you are getting as you are reading, you convert it. That's very important. Okay, so they have given t, they have given the value of t, and they have also given dt by dt.
Yes, sir.
Okay, that value also they have given. These two values they have given, correct? It is increasing at this rate. What is the pulsar's angular acceleration? Okay, so having given these two values, they are asking this value. First question. Okay, second question and other things, let us look at it later on, because we need to solve the first one. So B part and C part, you can solve this one. So with this information, whatever they have given, okay, so can you find out alpha? So here you see T is given, dt by dt is given, right? And you have to find out alpha. Can you find out alpha? Simple. Come on, do it.
Yes, sir. Yes, sir.
I hope this much information you have gathered by reading.
Yes, sir. Yes.
Right? They are giving this T, they are giving dt by d, they are giving T, you have to find out alpha. So the immediate thing is for alpha is what? Alpha is equal to d omega by dt. So since they are given T, you can find out the equation for omega. Right? So omega will be equal to 2 pi by T. Right? Now you want to get dt by dt is given to you. Okay? dt by dt. So and the information the information for omega is in T.
Yes,
So you simply differentiate this equation. You will get d omega by dt. So here d omega by dt, okay, will be equal to this T will go there. So you will get here 1 by T square. Okay, 2 pi will come in the numerator. 1 by T square into dt by dt.
Yes, sir.
Differentiate and get. Okay, and plug in the values. So you will get alpha.
Yes, sir. Minus 5 or plus, sir? Minus 5.
Minus 2 pi by T square.
Not that. Not that. There, but 1.26 into 10 raised to minus 5.
Minus 5, minus 5, minus 5. This is 1.26 into 10 to the power of minus 5 seconds per year. Now, why are you writing that? I am not understanding why. Because dt by dt, right? Alright. So you substitute those values here, you will get alpha. Okay, friends?
Sir, dt by dt how?
How you got no? He has written, they are given. See.
Yes, sir. What did we differentiate?
We differentiated omega, man. Omega is equal to 2 pi by t. We differentiated omega. D omega by dt.
Yes, sir.
We will get it as if we differentiate this. See, now t is a variable here. T is not constant here. Understand?
Yes.
T is not constant. It is variable with respect to time. So this differentiation gives you 2 pi minus 2 pi by t square dt by dt.
Okay, sir.
Yes.
Yes, sir.
Now, if its angular acceleration is constant, how many years from now will the pulsar stop rotating?
Yes, sir.
And see here, the pulsar originated in supernova explosion since the year 1054. So this pulsar started in 1054. What is the initial T of the pulsar? Assuming constant acceleration is the pulsar, and this has appeared in the examination 1992. So if you are students at 1992 and you are answering this paper, so they have asked you what was the initial time period of the pulsar.
They are trying to create height.
Understood? So you take this as the year you are writing and you have to calculate. Anyway, if the angular acceleration is constant, how many years from now will the pulsar start rotating?
Yes.
The pulsar originated in the year 1054. What is the initial time period? Initially, see, the pulsar was rotating like this. Now it is slowly rotating.
Yes, sir.
So,
We can find omega naught.
Yes, you have to find out omega naught at the time 105. So 1054, you put it as t is equal to 0.
Yes, sir.
Small t is equal to 0. And small t, and now the present time is what? 1992 minus 1054.
Yes, sir.
What will that give you? So many years. So 1992 minus 1054, that should give you 8 and 8. 938 years. But years no, because our pulsar and all is in seconds.
Okay.
So 938 years into how many seconds per year?
Yes, sir.
Okay, so per year we'll have approximately 3 point how many seconds?
So the 36 will leap year also.
Leap year also. Yes, you're right. Leap year also. Because only leap years will come here. Okay, so you will calculate the number of seconds that has originated in this, including the leap years. Very good, very smart. Okay, and multiply it by the years. So you will get so many seconds. Okay, so many seconds, and you will have to find out the initial time period. So you will find out from this omega naught.
Yes, sir.
So from omega naught, if you get, you will say omega naught is equal to 2 pi by t, or t naught will be equal to 2 pi by omega naught. You will get the value.
Yes, sir.
Did everybody follow?
Answer.
Yes, sir. Yes, sir. Yes, sir. It's a very lengthy calculation.
Hey, what lengthy, man? At this stage, this should be trivial. You should be able to do it without pen and paper.
Yes, sir.
Forget
Yes,
it.
sir.
Come on, you can do this. You can do it orally. Yes, Farooq.
Means sir, in this sir, we have omega is given and omega not we have to find, no, sir?
Omega naught you have to
In
find.
this case, omega is like that.
Yes. Omega naught you have to find. Once you find out omega naught, you will get T naught. T naught will be the initial.
Say, yeah.
Sure.
Advanced.
Yeah, exactly.
Huh?
Yes.
No. See, you have to
Just
come out of, listen, I can understand your inquisitiveness and all. But what I'm trying to tell you, as days are progressing, you should become more and more, focused.
Yes, sir.
See, the chulbulitana in it should start vanishing. Okay, it's nice at this age, we have to be chulbuli, we have to crack jokes and all. But as days are progressing, you should become very, very serious students. Because lots of data, lots of information, lots of knowledge, lot of skills, you have to hold it. And you have to quickly use many of these things. Okay, so it's a training period where, your mind should not get defocused. So therefore, if there is something which is not necessary, don't do it. Even eating food, if this is healthy, it is going to help me to learn, to become knowledgeable, I will eat. Otherwise, I will not eat. That should be the attitude of every student. Okay, something which is, time passing, all that you should leave. Okay, bore. See, there's nothing like, bore and all for you students. Okay, right, please. Maybe. That's why I've written some examination. Okay. Okay, so I suppose all of you got the strategy, students?
Yes, sir.
Right. See, I'm just trying to save your time so that, we can learn more in a given time. Okay, trivial calculations and all, I'm sure you will be able to do that. Mainly, capturing the problem and making the strategy for it and working is the main thing for us. Right. Yes, our approach was also correct. So, we have listed what are the given things here. So, here omega 2 pi and angular acceleration insurance are excellent. So, we got this, and then we got alpha is equal to 2 pi by omega, because they are given initial omega naught. 0.333 is what?
Time period.
Time period. Initial time period they are given time square into so and so we got this.
So got the sir, one minute, sir. dt by dt they have given the value, no, sir, like 1.26, sir. Again,
divided by year.
Yes, sir.
second per unit.
Divided by year. Years and 8 seconds.
dt by dt they are given as a 1.26 into 10 to the power of minus 5 seconds per year. Then you have to convert it into that you have convert. See, this is read that. Read that. Correct it. No. You clarify it. Huh? Time period 0.033 seconds. And you see here the rate is 1.26 into 10 to the power of minus 5 seconds per year.
Per year. Yes, sir.
Understand? So the time is increasing time is increasing. Time period is increasing 1.26 into 10 to the power of minus 5 seconds every year.
Yes, sir.
Yes, sir.
Okay. But now we have to convert this into so many seconds it is losing per so many seconds. That year is converted into seconds.
Okay, everything is taken in seconds.
Yes, that is what is to be done. So, now this is another problem. So try to capture this problem. This is again asked in an examination.
State board.
Board?
State board.
State board. This is as I keep telling you, these are all problems taken from engineering textbooks. A turntable. Turntable means a table which is turnable.
Yes.
Yes, sir.
He is rotating on a horizontal plane about a vertical axis, passing through the center with angular velocity so and so. It carries upon it a flywheel rotating with angular velocity 40 radians per second. See, flywheel is what you know, cycle, no? Cycle. So, cycle you have got, see, near the pedal there is a wheel. What is that called? Pedal wheel.
Yes.
There's a paddle wheel, right? Cycle you pedal, the paddle wheel will go, and there is a chain mechanism which will go and get connected to the rear wheel. But to the rear wheel there is something called, there is a spoked this one. What is that? That is called flywheel. That is called flywheel. So what does it do? So you pedal 10 times and stop pedaling. Hello, you pedal 10 times and stop pedaling, but the cycle keeps moving, no?
Yes, sir.
Yes, sir.
So there this flywheel is continuing to rotate. Right? Hello?
Yes, sir. Yes.
Yes.
Now here try to understand. So here or otherwise you see now you put the stand to the cycle and it's not on the road. पहले वाले साइकिलों में था क्या होता है वो व्हील ऐसा रहता है तो स्टैंड के ऊपर the wheel is standing on the stand and then you have the chain mechanism and then there is a paddle wheel here, right? And then of course now I have to draw a cycle here. Okay.
We can bring a cycle here.
Okay. The cycle here, right? So this wheel is also big and this one. So what do you do here? There's the pedal wheel, correct? There's a pedal here. So you rotate this pedal. So this will also rotate. Now you stop rotating the pedal, but this will keep rotating. Correct?
Yes.
So what happened here? Whatever work you did here, so this work that you did here, it got converted into kinetic energy or rotational kinetic energy. So through the chain mechanism, this rotational kinetic energy is transferred to the flywheel. And the flywheel is rotating along with this wheel. Hello? Now you stop rotating this. Okay, you don't do work on this. But the flywheel, this wheel keeps rotating. That means whatever work you did here, you created the kinetic energy, and this kinetic energy is preserved or conserved here. Understood?
Yes, yes, sir.
That kinetic energy is conserved. Okay, of course, in the reality, after some time the wheel will slow down and come down. Why? Because of the friction here. So if there's no friction, it would have continued. So The job of the flywheel here is to keep the wheel rotated. That's precisely what happens in your bicycles. Right? Okay. So the job of the flywheel is that. So there is a turntable which is turning, and there is a mechanism by which there is a flywheel, and that flywheel is rotating. The turntable is going like this,
Yes, sir.
and the flywheel is turning like this.
Yes, sir.
These are the two arrangements. I hope you got this.
Yes, sir.
Everybody got it?
Yes, sir.
Yes, sir.
So nice of you. Anyways, I thought my hand explanation and all will not convince you. You will have questions. I hope all of you got it. But still, I am ready with the one diagram for all of you.
Yes.
हाँ.
DC motor.
Yeah.
ये ನೋಡಬಾರ್ದು ಅದು ನೋಡ್ತಾ
Sir, ಅಲ್ಲ sir, DC motor.
ಎಲ್ಲೈತಿ ಡಿ ಸಿ ಮೋಟರ್ ಎಲ್ಲಿ ಬರ್ದಾರ
ಕಾಣ ಸರ್.
ನೀವು ಇದ ಹೇಳ್ಕೊಳ್ಳಿ, ನಿಮ್ಮ ಫೋಕಸ್ ಅಲ್ಲಿ ಕಳ್ಕೊಬೇಡ್ರಿ ಅಂದ್ರೆ ಕೇಳಂಗಿಲ್ಲ ನೀವು. ಸುಮ್ಮನೆ ಏನಾರ ಹೋಗ್ಬೇಡಿ, ಈ ಡಿ ಸಿ ಮೋಟರ್ ಅನ್ಕೊಂಡು ಇನ್ನೊಬ್ನ ಅವನ ಹೆಸರು ಡಿ ಸಿ ಮೋಟರ್ ಅಂದ್ರೆ ಏನಂತ ಕೇಳ್ತಾನೆ, ಆಮೇಲೆ ಇನ್ನೊಬ್ನ ಮೋಟರ್ ಏನಂತ ಕೇಳ್ತಾನೆ, ಶುರು ಮಾಡಿ. ಸಿ ಅನ್ಫಾರ್ಚುನೇಟ್ಲಿ ದಿಸ್ ಕ್ಲಾಸಸ್ we have to make it very effective and efficient. Time is very less for all of us. Okay, right. You can see here that this is the turntable which is rotating, and then there is a flywheel. Got it?
Yes, sir.
Hello.
Yes, sir.
Right. Now, it carries a flywheel rotating with angular velocity. This one. That means this is having angular velocity 40 radians per second. And this is having angular velocity 40 radians means it is turning like this. So the velocity vector is pointing towards you.
Yes, sir.
So 40 units of velocity vector is pointing towards you, and the turntable is rotating at 20 radians per second. That means
Yes.
this omega is 20. So you got 1 omega 20 here, turntable omega. Got it now? And this is 40.
Yes.
So you have two velocity vectors, right? Now, find the angular velocity of the wheel as seen by the observer in the room. Now you are sitting in front of me. Mr. Dimant is sitting in front of me. Swaroop, Arun are all sitting in front of me. So they are seeing this rotating and this table also rotating. But now as students of physics, this is rotating means you will see a velocity vector. Which angular velocity vector? Pointing towards you, and another angular velocity vector like this. Now, so this is turning like this, you are seeing this velocity vector, this velocity vector. So find the angular velocity of the wheel as seen by the observer. How will you tackle this? Now, see, you got the resultant of the angular velocities. Are you able to get that?
So that rotating table will not be upwards.
Rotating table is rotating like this,
table is
man.
rotating, yes.
Angular velocity is up, no?
Angular velocity is upset, then for this one, sir, flywheel, sir, then it will be like this.
Only flywheel if you take, flywheel is rotating like this.
Yes, sir.
So angular velocity of flywheel is pointing towards you. Turntable is rotating like this. The angular velocity of turntable is up.
Yes, sir.
So you have two velocity vectors. Did you get my hand?
Yes, sir. Yes, sir.
Yes.
So can you show what's done?
What do you want me to show?
Your video was getting stuck for me.
My,
so can you
okay.
show?
Right. Now, see, this is the turntable. Right? Neela, say yes or no?
Yes, sir.
Turntable is rotating like this. So the angular velocity of the turntable is my left hand, which is gone up.
Yes, sir.
And the flywheel is placed on the turntable and it is rotating like this. So the angular velocity vector of the turntable is towards your face.
Yes, sir. Yes, sir.
Yes,
Got
sir.
it? So these are the two. And now you are seeing both these vectors. So what is the question asked? Find the angular velocity of the wheel as seen by the observer. Angular velocity of the wheel. So how will you tackle this problem? I hope all of you got the problem. Now think and answer this problem. One student has come out with one answer.
Sir.
Okay, now what you do, listen. See, now what you do, this is the first time you are handling omega. So finding it difficult. Now what you do, think of a person, now listen to me very carefully. A person is moving like this. A person is running like this. Hello?
Yes, sir. Yes, sir.
So if you are seeing the person running like this, what is the velocity of that person with respect to you? This velocity.
Yes, sir. Yes, sir.
Right? Now the person is, now forget this. You see another person running towards you. So what is the velocity of this person running towards you? Towards you.
Yes.
Yes, sir.
So now you have got two, supposing both are happening simultaneously. He is running like this. See, actually he is sitting on a table. The table is taking him like this. But at the same time he is running towards you.
Yes, sir.
Yes, sir.
Then what is the velocity of this person as seen by you?
The angle.
The resultant of these two velocities.
Yes, sir.
You will feel as if the person is running in this direction.
Yes, sir. Yes, sir.
This is one situation. Now same way you do, no? Same way you do, no? Right? The angular velocity is towards you of the flywheel, and the flywheel itself is moving on the table like this. Hello?
Yes,
Up, sir.
Up,
Yes,
up,
sir.
up. Okay, up. So the resultant is like this.
Yes, sir.
Yes.
Yes,
Nice.
Yes, sir.
Got it.
So you see now, because this omega, it is, you are getting used, you have to still get used to that, and now wherever you get it, you create an analogy like this and do. So here there is the resultant of these two. Here also there is the resultant of these two, because now you don't start seeing omega means it is turning like this, so I should also turn like this. All that you will start, because you will start imagining it is turning like this as an observer, how I will see that and all. So that is why you see this vector omega bar has been created so that I and you will not keep turning. We just have to understand, we just have to interpret this.
Yes,
So what it means, the resultant of these two is like this means what? That means if you keep a vector like this, that means the person will see this flywheel turning like this.
Yes, sir.
Yes.
Sarup is so happy. See. Right, did you all get it?
Yes, sir.
Yes, sir.
Right.
25 answer.
That's bad.
25.
See, you see, this is the problem with
Sir,
you.
no, sir, like it. Simple.
Okay, right. It is simple. Right.
Others are not.
20. But I will not give full marks to you,
Read
because you didn't say the direction. You only gave the magnitude. That's like school children. Yes, gentlemen.
Sir, here the angular velocity vector is changing at every instant, so in the axle tension.
Angular
Yes, sir.
Resultant angular velocity.
resultant angular velocity is changing. Right?
Why?
Sir, for the turntable, sir, it will always differ.
I know,
Sir.
sir.
For us, the flywheel, sir.
I know, sir.
At one instant
Sir.
like this, other instant like this.
Then because
So
the
the
angular
resultant
velocity of flywheel, sir, it is velocity vector is
I know, bro.
See, now for an observer in the room,
Yes, sir.
okay, what is he going to see? Just here, you at this instant, the resultant is like this, isn't it?
Yes.
Now what you are trying to see is it is not the angular velocity vectors are constant; they are not changing.
Sir.
Hello. But the direction of this resultant is changing.
Yes, sir.
Yes, sir.
The direction of the resultant is changing, therefore it is accelerating. No doubt about it. No doubt about it. Okay, but that is not the question they have asked. Right?
Second,
Direction of
forward, specify the direction of the net.
At that instant, this is the direction, man.
Instant.
At that instant, this is the direction. That's it. Over.
Yes.